So let's start the second part of my talk. So in the second part, I will explain our main theorem. So classification of non-degenerate singularities. As a corollary, we obtain so-called the duality of singularities. So among the non-degenerate singular points on CMC1 faces. So let's start. So first, I have to explain what is a non-degenerate singular point. So a smooth map F is called a frontal if there is locally a unit normal vector field. There is a unit normal vector field along F locally. Then a frontal F is called a front if the pair of these maps F and nu defines an immersion. So this condition is in fact this is equivalent to the pair of the map F and nu defines a Legendre immersion into this contact manifold. So R3 cross S2, S2 implies the unit sphere in the Euclidean 3 space. So R3 cross S2 is regarded as the unit tangent bundle of Euclidean 3 space. So this manifold has canonical contact structure. Then this condition is isotropic condition, and immersion condition implies this map is a Legendre immersion. Anyway, so for frontal or fronts, we can define this function lambda by this way, determinant of this 3×3 matrix, where UV is a local coordinate system, local coordinates of M. Then, for a frontal F, a singular point P is said to be non-degenerate singular point if so P is a zero set, zero of lambda, this function lambda, and the exterior derivative of lambda at P does not vanish. So in fact, this function is identifier of singularities. That is, the zero set of this function is coincides with singular point, singular set of a map F. So this condition is essentially implies the non-degeneracy of singular points. So in fact, by the implicit function theorem, so for non-degenerate singular point, there is a regular curve such that the singular set is parameterized by this regular curve. So such the curve is said to be a singular curve. So this curve parameterizes the singular set of F. So it is known that these notions are invariant under coordinate changes. So invariant under A equivalency. So non-degenerate singular points can be defined of frontals in 3 manifold. So in particular, Dojita 3 space. CMC1 faces is CMC1 faces are frontals. It is known that such a surfaces are frontals. And we can say our main result is this. Any non-degenerate singular points on CMC1 faces in Dojita 3 space must be one of the following 1, 2, 3, 4, 5, 6. So A2, A3, A4, generalized AK, generalized cone-like singular points. These are singularities of front, wavefront singularities. And these are non-frontal singularities. It's about frontals, frontal singularities. And also, I will explain precise definitions of each singular point later, but this class 5 singular point is defined by wireless trust data. I will explain this also later. So, but direct corollary of this theorem implies this. So CMC1 faces of Dojita 3 space does not admit fourth singular points. So fourth singular points appeared on Mach spaces when such Mach spaces changes causal types. So there is a big difference between CMC1 faces and Mach faces. So first one is generalized cone-like singular point. I will explain the definition. So as in the first part, a cone-like singular point is defined by this standard form. So the standard form implies these conditions. F is a front, and the singular point is non-degenerate, and the image of singular curves is single point. So according to these conditions, we can define generalized cone-like singular point. A smooth map F has a generalized cone-like singular point at P if F is front and P is non-degenerate and the image of the singular curve gamma is a single point. So cone-like singular points are generalized cone-like singular points. Next, what is AK-type singular point? So AK-type singular points are defined by the standard form of this map. The image of FAK, this map, coincides with this set, where F is this polynomial map, polynomial function. So this set implies, so the set of double roots of this polynomial. And also I want to see, so for K, is 2. This singular point, aka A2 singular point, coincides with capital H, and A3 coincides with swallowtail, and A4 is usually called capital butterfly. So the properties of AK-type singular points implies the following conditions. So according to this fact, I want to define generalized ones in this way. So a smooth map F has a generalized AK-type singular point at P if the following three conditions hold. So first one is F is a front on a neighborhood of P, and second one is P is a non-degenerate singular point. And if we set the function delta by, so the gamma prop and the determinant of gamma prime and eta, where eta is a vector field along gamma such that so eta points in the direction of the kernel of the df. Then if we set the delta, then delta satisfies this condition. So AK type singular points satisfies this condition. So, but so AK type must be generalized AK type by definition. But for K is 2, 3, 4, it is known that generalized AK coincides with the class of AK. So that is converse hold. So this fact was proved by these papers. So, and finally, so the last singularity is 5/2 capital H. So 5/2 capital H is given by this standard form. I want to remark that 5/2 capital H is on Mach spaces does not exist. So capital H, so this is a figure of standard form of 5/2 capital H. So this figure is very similar to usual capital H. So this map is defined by in this way 5/2. And this map is given by this standard form 2 and 3 capital H. Okay, so our main theorem implies non-degenerate singular points must be one of these following this list. So as a corollary, we obtain so-called duality of singularities. So so for the duality, I want to explain what is conjugate Mach spaces. So this is a representation of Weierstrass type representation formula for max faces. So let M be a simply connected domain, and Z0 be a base point, and G be a meromorphic function, and omega be a holomorphic one form of M, such that this is a Riemannian metric on M, bounded Riemannian metric. Then Fz gives a max face. Conversely, any max face is locally given by this way, so this is so-called Weierstrass type representation formula. Then the pair of meromorphic function G and holomorphic function, holomorphic one form omega, is called the Weierstrass data of F. So using this formula, we can define the conjugate max face by the imaginary part of this holomorphic null curve. Simple calculation implies that Weierstrass data of this conjugate max face is given by this way. So G is preserved and omega deferred multiplying I. So there is a relationship between singular points of original max face and conjugate max face. If a max face F admits a capital H, then the conjugate max face must admit capital H at the same point. Similarly, if F admits swallowtail, then the conjugate F sharp must have capital cross cap. And also, if F admits A4, that is capital butterfly, then capital S1 singularities F sharp have. And finally, if F admits generalized convex singularities, then F sharp must have fold singularities. So this figure is the final one. So F admits generalized convex singularities, then F sharp admits fold singularities. So this is Weierstrass data, and G omega. This is the conjugate max faces. So this fact is proved by these several papers in these papers. So I want to consider the case of Dojita 3 space. If we identify the Minkowski 4 space, the set of Hermitian matrices 2 by 2 in this way, then Dojita 3 space can be written in this way and in this way. So this is just the symmetric space form of Dojita 3 space. Then, so Fujimori, Ayama, Akutagawa representation formula gives so-called Bryant type representation formula for CMC1 faces in Dojita 3 space. So basic items very similar to max faces M is a simply connected domain of C, and Z0 is a base point, and G is a meromorphic function on M, and omega is a holomorphic one form on M, such that this is a Riemannian metric on M. So let F be a solution of this ODE initial value problem. Then small f defined by in this way gives a CMC1 faces in Dojita 3 space. So this is a representation formula for CMC1 faces. So as in the case of Mach spaces, duality of singularities, we can define conjugate CMC1 face by this way. And sorry, these G and omega is called the wire thrust data of CMC1 faces. And via wire thrust data, we can define conjugate CMC1 faces in this way. And then, as in the case of Mach faces, we can prove it is known that duality of singularities. So if F admit capital H at P, then at the same point, F sharp has capital H, and also if F original CMC1 face F admits swallowtail, then F sharp must admit capital cross cap. So this capital H is self-dual, and swallowtail and capital cross cap are dual to each other. But for other singularities, such the dualities were not known. So we proved duality of singularities among all non-degenerate singular points in this way. So as in the case of Mach spaces, so the duality of singularities are the same in the case of Mach spaces, but for A4 capital butterfly singularities, we can prove that the conjugate surface must have one of capital S1 plus or S1 minus singularities, or the type 5 singularities. And also, such the singularities, the conjugate Mach space must have A4. So, such the phenomenon does not occur in the case of Mach spaces. In particular, Mach spaces does not admit CS1 plus, but CMC1 faces does admit CS1 plus. And also, we found this singular point, this mysterious singular point. So this is not found before the importance of these singularities. And this is, we do not know what is a singular point, but we recognized by the classification table. And also, we can prove for AK and SK, generalize AK3 and CSK plus. And finally, so the conjugate of generalized cone-like singularities. In the case of Mach space, this is a fault, but CMC1 phase does not admit fault singularities. So this is also a phenomena only for CMC1 phases in Dojita 3 space. So this is a figure of cone-like singularities and the conjugate CMC1 phases. So conjugate 1, we can easily observe by this figure that this is not for the singular point. So what is the singular point? According this table, we have this is 5/2 capital H. So that's all my talk. Thank you for your attention. So this the contents of my talk can be seen by this paper. So if you like my talk, then please refer in this paper. That's all. Thank you very much. See you.